Hello, Matthew Bell with Alzheimer'sProof.com, and today I want to attempt to answer a viewer's question. So a viewer commented on the video that I did in a private message on acetylcholinesterase inhibiting drugs. So it turns out, just as a background of the question, the viewer is acetylcholinesterase deficient, and the deficiency was discovered after a particular drug was administered in a particular medical procedure, and this person had an emergency essentially in terms of breathing, and it turned out that this was because the individual was deficient in acetylcholinesterase, and the body didn't rid the drug like it was supposed to in this procedure. But the questioner essentially asks whether this deficiency might actually serve to help prevent Alzheimer's disease. But first of all, I appreciate the confidence and I appreciate the question. I am not a medical researcher, I am not a doctor, so the reason I'm even attempting to answer this question is because I think there's a sense in which the question has a logical component to it in terms of just the structure of the question and the structure of the issues involved. And so I think, independent of what the evidence shows, there's kind of a way of getting a fix on what the range of possible answers might be. And so that's essentially what I thought I would just comment on briefly. But this video is not to be construed as medical advice or as advice of any kind, simply for general informational or entertainment purposes. To get actual medical advice, of course, you would need to seek out a licensed healthcare professional in your area, somebody familiar with your situation, and bringing the question to them is going to be superior in terms of the actual medical facts involved. But the question essentially, again, has to do with whether an acetylcholinesterase deficiency can help to prevent Alzheimer's disease. Now, the first thing that I want to say about the question is that it depends upon a mechanism. At least viewers should understand that the way in which acetylcholinesterase drugs work. And for the fuller explanation, go to the video that I actually produced on this question. But the basic idea is that people who have Alzheimer's disease have been found to be deficient in a neurotransmitter called acetylcholine. Now, one strategy for trying to raise the level of acetylcholine in a person's brain is to actually counteract a chemical that's designed to break acetylcholine down. Now, it gets a bit confusing, so once again, I invite you to check out the video where I go into this with some visual aids that I made, and hopefully it's a little bit understandable. But the basic idea is that the acetylcholine level is raised in a kind of a backhanded way by trying to prevent the stuff that's there from being broken down. Now, the question is, if a person is naturally deficient in acetylcholinesterase, then their body is going to naturally be unable or less able to break down the acetylcholine that there is. So the basic idea here is that, is it possible that a person with an acetylcholinesterase deficiency might be less likely to be deficient in acetylcholine because they don't have the ability to break the acetylcholine down? And so the idea, I think, is supposed to be that might leave more acetylcholine in place and then make it less likely that a person's going to run out or become deficient in acetylcholine. Now, the question is not absurd at all. There is a plausibility to that. We'll get more into that in just a minute. But there's also a sense in which there's an intuitive plausibility to the fact that a deficiency could also have some kind of a positive benefit. So the example that came to my mind was in terms of sickle cell trait for hemoglobin. So some people have certain of their blood cells take a crescent or a sickle shape, and this causes a number of negative health effects. So the blood cells don't have the normal circular shape, so they don't pass as easily through the blood vessels. They can clump together, they can cause health problems, they can shorten life expectancy. But beyond those negative qualities, a person with this sickle cell trait also has a certain level of protection against malaria. So even though the sickle cell trait is generally bad and can cause anemia and other conditions, it also has a positive benefit. Now, I'm not saying that the relative benefit outweighs the deficits. I'm not saying that. I'm just saying that here you have a sickle cell trait which has some obviously negative qualities, and yet it does do something positive. So even if an acetylcholinesterase deficiency does have a number of negative consequences, and in this individual's case, obviously a health emergency arose during a medical intervention, So there at least is some danger, apparently, to having that deficiency. But at the same time, is it possible that it confers some kind of an advantage? And of course, the answer is yes. But for this to be the case, I think there's got to be at least two things in place, possibly three. And to unpack those, we'll just kind of get into a brief discussion of the causal hypotheses. Now, once again, I have an entire video. I'll put the link in the description. I have an entire video that just gets into the causes. It might be worth me redoing it at some point because it was one of the first ones, but a number of causal hypotheses exist for Alzheimer's. There is no one agreed upon cause for Alzheimer's disease. Now, there are a number that take the four. So, for instance, it is the case that many researchers believe it is acetylcholine deficiency that causes Alzheimer's, but at the same time, other researchers say no, it is the accumulation or the aggregation of various protein deposits in the brain, and these could be called beta amyloid tau protein. So the beta amyloid plaques generally are going to form in between nerve cells and interrupt neural communication. Then you've got the tau neurofibrillary proteins that can gunk up the actual nerve cells themselves inside. And so there's just a number of things. How they interact, which one is primary, these are all going to be disputed. And so it may turn out that the aggregation of plaques and tangles causes an acetylcholine deficiency, or it might turn out that the acetylcholine deficiency causes the plaques and tangles, or none of the above. And again, I'm not a researcher, I'm not speaking to what the evidence actually shows. It's simply the case that when you have two things, let's say X and Y, it could be the case that X causes Y, it could be that Y causes X, it could be that both X and Y are caused by some third thing, Z, and it could be that they're causally unrelated. So it's possible for those directions to go either way, and that's just the options that are there in logical space. But beyond those main hypotheses, there are a number of other different causal hypotheses for Alzheimer's disease. So some people think it might be caused by chronic brain inflammation, oxidation or oxidative stress. Some people think no, it could be caused by a decrease in various hormones, estrogen, testosterone, that occur as people age. It could be due to exposure to various toxins. Some people think it's a nutrient deficiency or a series of nutrient deficiencies, and many other things besides. Some people actually hold the view that it could be caused by an infection. Number of different things. So the first point to this viewer is, if it's the case that an acetylcholinesterase deficiency is going to help guard against Alzheimer's disease, then it has to be the case that acetylcholine deficiency is part of the causal explanation. It might turn out that way, but it might not. So if it turns out that acetylcholine deficiency is simply secondary, or if it's down the road, or if it's simply correlated but it's not causal, then an acetylcholinesterase deficiency really, by all accounts, is probably going to be irrelevant. But even if the acetylcholine deficiency does turn out to be a major part of the causal explanation, a second thing has to be the case as well, and that's going to be that the acetylcholinesterase inhibition is going to be the primary intervention. So in other words, if it turns out, even if it turns out, that acetylcholine deficiency does have some causal role to play, it would also have to turn out that the acetylcholinesterase inhibiting drugs are the main way of addressing that concern. And those would have to be the primary way of treating the acetylcholine deficiency. And in fact, with regard to this, there's some reason to doubt this, and there's a number of different reasons for it. As effective as some of these drugs are, and here we're thinking of things like Aricept, Razidine, Exelon, some of these drugs that have an acetylcholinesterase inhibiting component, they don't seem to be effective at curing Alzheimer's disease. They're not cures. They might be effective at increasing brain function for a limited time, but then they lose effectiveness after a period of time, and for the different drugs it's probably going to be different. But the point is simply that as effective as they might be for a short interval and within a certain spectrum of measurement, they don't seem to be the end-all be-all in terms of the actual treatment for Alzheimer's disease. But then that suggests that there's going to be more to the picture of intervention than just acetylcholinesterase inhibition. One of the reasons that's given for why these drugs are not simply cures is because they don't address the fundamental acetylcholine deficiency. All they do is try to preserve the acetylcholine that is there in the brain for a little bit longer. But whatever it is causing the acetylcholine level to drop, presumably it's continuing to cause that level to drop. And so at some point in time, the acetylcholinesterase inhibition simply has nothing to work with, because the acetylcholine essentially goes down to a very low level and cannot be raised even with this mechanism. So I said maybe there were three factors, and I guess this is what I mean by the third. That would be that in a person who is acetylcholinesterase deficient, it would seemingly also have to be the case that their acetylcholinesterase deficiency is somehow caused or arranged in such a way as to protect them from having an acetylcholine deficiency, because it seems possible that a person with an acetylcholinesterase deficiency might also have a concurrent acetylcholine deficiency. And if that's the case, then there's nothing stopping that acetylcholine level from continuing to drop, even if their body has a deficiency in acetylcholinesterase, and therefore the acetylcholine levels may not drop as fast as in somebody else. They're still going to drop if there's a causal mechanism at work that's causing them to drop independently of the acetylcholinesterase deficiency. So once again, I am not a medical expert by any means, but I just thought I would reach out because I appreciated the question. I wish the viewer all the best, and I will be thinking about that question as I do future research. It might turn out that there's something relevant in terms of some of the things that I've read, or in terms of some of the things that I will read in the future. So I will be on the lookout for that. If anybody else has a question and they want to present it, you can feel free to do so. I think the viewer contacted me through the contact form on the website, alzheimersproof.com, but I invite anybody to drop a comment, drop me a question through the website, and I will do my best. I am at work. I had a previous questioner ask about various natural sweeteners, and I am in the process of creating the video content for that, and my answer for that just took me a long time to put together. But for the time being, I will leave it there. If you found something of use in the video, I ask that you please like it, subscribe to the channel, click the notification bell to be alerted to new content as it becomes available. I thank you so much for being with me today, and I look forward to seeing you again in another video. Thank you.